We're going to start looking at our trig graphs by moving them side to side and up and down. Those are called translations, and in this context of trigonometry, we'll also call them shifts. So you have to look at these and understand that these will function just like our previous families of functions, where if you look inside the function, if you look inside of whatever trig function you're looking at, just like our other families of functions, that moves it side to side as a translation. And if you look outside the function, that moves it vertically up or down. And if it's vertically, it's the same as the number, and if it's inside, it's the opposite, just like we've done with parabolas, with square root graphs, etc. So this family of function is no different when dealing with them. So what our objective is to be able to graph sine and cosine using vertical and horizontal translations, and we'll even extend it to tangent and cotangent. So first of all, let's look at what the number in front does. So if we have a number out here, this is a vertical shift. So sometimes we'll call it translations, sometimes we'll call it shift. It means the same thing. Now, as an example here, if we have a 3 here, remember sine usually goes up to 1 and down to -1, and its midline is the x-axis. Well, this 3, when we add it on, is going to move the midline up. So we're going to go up to 3 units here, and from 3, we're going to go 1 above it and 1 below it, just like we did from the previous midline. So up to 4 and down to 2. The rest of the graph looks very similar. So what I'm going to do is I'm going to draw a new midline here. And this midline is just a guide. It doesn't have to be on the graph. It just reminds us that the axis used to be the midline. Now we've moved it up 3 units from there. That's the middle of the graph. Now we're going to go with laying out a period here. So sine's period is 360 degrees. I'm going to do this lesson primarily in degrees. You could do it in radians if you laid that out as 2 pi and worked from there, but I'm going to start with just degrees. I'm going to split that in half for 180 degrees, split that in half for 90, and then this one in half, I'm going by 90, so this will end up being 270. And now when I lay out my graph, remember sine starts in the middle, so my new middle is up at 3, that's my new midline, and from there I go up to the top, which is 1 unit above it, back to the midline, down to the bottom, which is down at 2, then back to the midline for the last part, so my graph of sine looks like this. So notice that's the whole sine graph shifted up 3 units, that's a vertical shift. Now we're going to do the same thing here now, only now we're going to look on the inside and we're going to deal with a horizontal shift. We call a horizontal shift a phase shift. That's oftentimes the phrase we will use as a phase shift. So this is horizontal in the opposite direction. So just a reminder, what that means is we're not going to do this one in the negative direction like that would seem to imply. We're going to go in the positive direction 100 degrees. So this one, I haven't vertically translated, so my midline still is at 0. So my amplitude still goes up to 1 and down to -1. I'm just going to shift this out though and start my graph at 100 degrees. So take the starting point, move it out to 100 degrees, and from there lay off my period being 360. If I add 360 onto this, I'll go out to 460. And then I'll split that in half. Now when you do these horizontal shifts, you're going to have to do some averaging. Unless you can, there's other ways to say divide the period by 4 to figure out what you go by. But this one I'm going to average. I'm going to add these two together. 100 plus 460 is 560. If I divide that by 2, I get 280. So it's just averaging those two. Now I'm going to do the same thing for these other 2 spots. Average between 100 degrees and 280, that's 380. Averaged out, if you average that out, I get 190. And notice I'm going by 90s, 100, 190, 280. So if I go 90 degrees further up, I get 370 and then up to 460. Or you could just average 280 and 460. So that's laying out my key points there. Now let's go ahead and graph it. Remember, on this one, sine is going to start right at the midline here. I'm going to go up to the top of the amplitude, through the midline, down to the bottom, and then through the midline. So notice that this is my sine graph shifted over a positive 100 degrees, so the opposite direction from what is implied there. Okay, so that's the basis of what we'll do. Let's do some examples down here. First of all, let's summarize what the different things on my formula do. So my graph formula, just a reminder that this number here, this is my vertical shift. So that moves it up or down. This number here is my amplitude. It tells me how far up and how far down I go from the midline that I've translated with the vertical shift. So midline up to the amplitude, and then take that midline, go that same number down to the bottom of the graph. This B here is what we usually use for the period. So this is affects period. Now just a reminder how it affects period. This is for sine and cosine, secant and cosecant. Their period is 360 degrees. So for sine, cosine, secant, and cosecant, it's going to be 360 degrees divided by b, or 2 pi if it were in radians divided by b. Okay, so that's what my period would be. For tangent and cotangent, their period starts out as 180, so it would be 180 divided by b, or pi if we're in radians divided by b. Now it's important to recognize that if there's a coefficient in front of the x, we need to distribute it out. So this x has to be by itself inside the parentheses. If there's a number in front of it, we'll take it out. I'll show you an example down here of what that looks like. Okay, and then this last number here, this is my phase shift. And my phase shift is the one that affects it horizontally in the opposite direction. So whatever you have plus or minus, you go in the opposite direction for it. All right, so let's do some examples down here. So if you look at this first one, okay, this number in front affects the amplitude. So this means I've got an amplitude equal to 2. I don't have a number being added or subtracted in front, so that means that there's no vertical translation. I'm not going to move the graph, the midline up or down. So I'm just going to go up to 2 and down to -2 on my graph. Then on the inside here, I've got to factor out that 3. So if you have this kind of expression, notice I can factor, distribute out the 3, because if I had thought that my horizontal translation, my phase shift, was 30 instead of 10, I would have been off. You need to factor it out so we have it properly. Then this 3 is what affects period. So the period is equal to, I'm going to do it in degrees here, so 360 divided by 3, so that's going to be 120 degrees. And then lastly, this 10, that's my phase shift. Okay, so let's go ahead and mark off our phase shift. That means I'm going to start out here at 10 degrees. So I shifted over 10 degrees from where we usually start on the axis. Now I'm going to go ahead and lay off one full period is out to 120, but that's 120 past my starting point. So I got to take 10 plus the 120, and that's going to give me 130 degrees out here. So I'm going to just make a note here that this is 10 degrees plus 120 to get out to the ending place of my one period. Now I'm going to split that in half. Now we do that by averaging. 10 plus 130 is 140. Divided by 2 is 70 degrees. You could then you split these two in half. 10 plus 70 is 80. Divided in 2 is 40 degrees. If I add these two, 70 plus 130, add them together, you get 200. Divide by 2 to average it, you get 100 degrees. Or you might see we're going by 30s, and so that might help you. Another way to do it is whatever your period is, if you divide it by 4, that will get you what each key point is going to go by on this for sine and cosine. All right, now for my graph, now that I've got all my important information laid out, sine starts on the axis, goes up to the amplitude top point, through the middle, to the bottom, and then back to the middle. So my graph looks like this for one period. Let's go ahead and try the next one. Notice the next one, we do have a number being added in front. This is my vertical translation. So that means I'm going to move the graph up 1 unit. So I'm going to move it up to 1 here. And then this 3 means my amplitude, that's above the new midline. So I'm going to do a midline right here at 1. So I've translated it up 1 unit. Now the 3 means I'm going to go up 2, 3, and 4, up to 4. And then I'm going to go down from there. Notice I've got to go down 3 from the 1. So I go down 1 to 0, then -1, -2. So it's 3 units below it. So you got to count from the new midline as to where those go. I don't change the period at all. I don't horizontally translate it. So I'm going to still have a period equal to 360. So I'm going to go out here to 360 for one period. Half of that's 180. Half of that is 90. And halfway between those two is 270 if I'm going by 90s. Now remember, with this vertical translation, you've got to start your cosine at the top of your amplitude. So I'm going to start up here at the 4 on my axis because I haven't changed it. Then it goes to the midline at the next one, down to the bottom of the amplitude, to the new midline. Don't stop at the axis, go up to the midline, and then all the way up here. So I'm going to mark here, this is my midline. That's what I have to go to. So here's my graph of cosine. So notice it's been translated up 1 unit and stretched to go up 3 units above and below that midline. All right, let's go ahead and use these same concepts for tangent. That really it applies the same. We just have to remember that the period for tangent, the period is equal to 180. So don't forget that. Now there's no number here to change the period. And also I haven't moved my midline up or down. If there's like a 3 here, you'd move the midline up to 3. All I want to do is translate it over 120 degrees. So if this is 120 degrees here, that I've translated it over, what we think of is to do our one period, we go half a period back to, we go -90 degrees this direction back to 30 degrees to get my first asymptote. Remember, so this is, notice that from here to here, this is 90 degrees, half of it. So I'm going to go 90 degrees out here to get to my next asymptote. So I'm going to go out here to 210 degrees. There's my next asymptote. And then I draw my tangent like this, going up, sloping up like the shape of a tangent does. So what we've done is we've added to our graphing the capability of translating the graphs. When we translate it horizontally, we call it a phase shift. It goes in the opposite direction. If we've got a negative here, we're going to move it in the positive direction. If we've got a positive, we'll move it in the negative direction. And then we've also worked with having a number in front where we add or subtract. That moves the midline, vertically translates it by moving the midline up and down. and then you follow your guidelines for amplitude and for period to draw the rest of your sine, cosine, and tangent. And also we could apply this to cotangent, secant, and cosecant graphs.